Hello, everyone. Welcome to the .NET Docs Show. We're going to have 60 minutes of unscripted .NET entertainment. We are doctors of .NET, so we're going to be driving healthy choices in .NET. I hope you're ready for it. I'm your host, Myra Wenzel, with my co-hosts, Kim Soper and Luis Quintanilla. And today, I'd like to welcome our today's guest, Konrad Kokosa. Konrad, how about you introducing yourself to us?
Hello, everyone. I'm Konrad. I live in Poland, and in general, I am .NET programmer, developer, trainer, and doing other stuff related to .NET. So I thought it will be nice to share something with you and share something that I'm doing because .NET is awesome. So I just wanted to share a little part of this awesomeness.
Thank you, and we're gonna have some awesome Blazor and Azure functions. I know we're gonna have fun with it. Before we head into that, let's have Luis to cover our I forgot the name of our section. It's the checkout.
All right, so Conrad's probably going to show us an example here of how you go about doing this process for his application and for his game here. But if you're interested in building something similar, or at least the components that make up a lot of what Conrad's going to be showing us today, you can head on over to this document here, which is called, it's a tutorial on building a static web app with Blazor in Azure Static Web Apps. Now, in this case, you're going to need a GitHub account as well as an Azure account, again, because you're going to be working with Azure Static Web App sort of service from Azure. So make sure to have those. And once you have them, essentially, you're going to be building an application that goes ahead and fetches data and provides a weather forecast for you. Now, some of the components that make up this application are an API, which is actually backed by Azure Functions. And what that does is it just gets some data and goes ahead and fetches it for you, which you then go ahead and display inside of the client, which is a Blazor WebAssembly project. All right. And then there's some shared components that are part of this application, which essentially you use or share, kind of like the name implies, between the API and the client for visualizing all of this weather information. Then it goes on and talks to you. This tutorial talks you through some of the components in this instance here. It talks to you about the fallback route, which is something that if it, for example, it fails or can't find whatever resource it is that you're trying to access, it will fall back and access whichever route you want to. And in this case, it's just going back to that index homepage of your web application. Now, although I mentioned that there were several components that make up this application, you actually don't have to go ahead and put them all together yourself from scratch. There's actually a repository here, which I'll be showing you in a second here. This static web app Blazor started, and this is actually a template that you can clone inside of your GitHub, sort of your GitHub account, right, to get you started with the main components that you're then going to go ahead and build upon, right? And again, there's those same sort of projects, right? There's your API, your client, and your shared application. If we go a little bit into the API, you're going to see that there's a single weather forecast function application, right? And all that's doing is it's getting a summary data, and then inside of this run, if folks are familiar with Azure Functions, right? This may look familiar to them whenever they access the weather forecast endpoint. They will be essentially given the data, and the data will be processed inside of this run function here. And then if we go back to the client for a second here, right, there's the client, and that's what's going to be displayed for us, and it's going to provide us with a really nice UI that Blazor gives us. It's really just going to be made up of that index page, right, and that's just sort of the welcome page, but the most important part is this fetch data, which is actually where your that table that we saw earlier, right? This table here is displayed for us. So that's essentially the gist of the application. Once you've built it, right, and you've cloned it, it's part of your repo, you create a repo for it, then you can go ahead and use Azure Portal or any other sort of medium that you use to, I believe you can use Azure CLI as well, probably even automate a lot of this stuff via CI/CD through GitHub Actions or Azure Pipelines. But essentially, you can go ahead and create your application or create a resource for it inside of Azure. And then you configure it, provide a few configurations in terms of where to find your repo, the application contain your repo, and you can go ahead and publish it from there. Once it's deployed, you're provided with a URL where you can access your application, and it's publicly exposed via the internet. And that's pretty much as easy as it gets. And one of the really nice things that I really like about this sort of way of building applications, right, is Blazor WASM. You can do it. It's relatively low cost in terms of, because you're not basically having compute that has to host this, right? It's just static pages that are being hosted. And with Azure Functions, it really provides you with a really low cost way of, if you're not, you'll only kind of pay what you use type of thing, right? So with that, make sure to give this doc a look, and get started building your static web apps, and with Blazor WebAssembly and Azure Static Web Apps. So with that, let me go ahead and turn it over to our guest, Konrad, who's actually going to show us how he went ahead and built an application using these components.
All right, Konrad, the floor is yours.
Thank you. So in general, I would like to give you a kind of description what I'm trying to build. By the way, I used exactly the same template that you have shown. So I'm even have a slide about it, because it is really nice kickoff of the project that we will be using this technology. So, but maybe let's switch to my presentation. I prepared some slides, so I will give kind of background about the idea, because I really found it super convenient to use this technology to write out-of-memory card game, because mostly exactly because of this, because of this template, because it nicely works with the serverless deployment and so on. So my idea was to try this technology, and I believe it really fits this particular use case. Just maybe more, because I have a slide about it, so I don't want to skip it. Just once again, I'm a .NET freelancer trainer trying to do various things connected with .NET, also meetups, trainings, and I'm also an author of this book, which is 2 kilograms, or in other words, over 1,000 pages. About .NET memory management, because I am, and this is important also in the context of of this game, I like to perceive myself like a .NET performance related guy, let's say. I really like internals, I really like memory management and other stuff which is related to this, how those all things are working. So I really feel I'm somehow connected with the whole internals and performance world in .NET for years. And because of that, and because we have created this .NETOS initiative, which is similarly about the same things, I thought it would be nice to have kind of idea to create super niche thing, which is game about .NET, and not only about .NET, but also about internals of .NET, let's say performance of .NET. So niche in a niche in a niche, because it's a card game, and it all started with a physical card game. So there is this site you can go and download the version to be printed, and it is kind of print and play prototype that everyone can use from this particular site. And the idea was simply to make it physical. So I was literally trying to prototype it like that, with a lot of small pieces of paper, and trying to, invent the whole mechanics in the card game. I'm not sure if you or maybe our people that were watching us now are playing card games, but in general there are various mechanics that you can use, and that was a pretty lot of fun to invent
Konrad,
how those things may work.
I have a relevant experience actually regarding the point that you just made. So so as many folks do, I know how to play poker. When I was in college, I had a Windows development class, and the final project was just like it was just an arbitrary project. You need to come up with an app that uses, you know, these Visual Basic controls, you know, a drop down, list box, whatever. And I saw the requirements and I thought, you know, those are dumb. And so I just threw them all out and I made a video poker app in Visual Basic.
Yeah.
So I've actually been kind of looking forward to this episode for you to this exact conversation that you've been talking about converting that physical card game to something. Anyway, that's my relevant point. Please continue.
Have some kind of fun, right? So the idea was to, and by the way, the very initial idea was to be only physical card game. So after inventing all these mechanics, I was starting to prototype the whole thing like this, and I even have 3 prototypes printed like that. When the whole idea of this game is about performance and memory management. So when you play games, and when you not games, but when you play a card, you consume some memory, but in turn you have some feature points. For example, when you see here, when you add some feature that is, for example, a mobile app to your let's say business application, then you get 3 points of free feature points, but you consume some memory and CPU, so on and so on. So the whole mechanics here is about consuming memory and CPU, but gaining some feature points, and the first player that gains some number of feature points wins. And also those, let's say, score sheets, which are, let's say, inspired by benchmark.net output, which is because benchmark.net is the king of performance. So I was trying to mimic here the tables of the benchmark.net itself. So those who are pretty nice, and I was having fun doing that, but it was pretty hard to, I mean, it is not even finished to, I know, feeling that all the mechanics are well balanced and so on. So I thought, okay, even before I will finish that, why not doing it simply a multiplayer online game? Because that would be very nice next step and also a lot of fun. And then the idea come about making it in Blazor. So maybe I will skip this video, which is explaining the mechanics. If you are interested, as I said, you can download it, you can print it, you can play with friends for free totally. And there is also this video which is explaining the first mechanics that are there. So just to have an example, what I'm trying to build is, as I said, the first player that wins, which gets some amount of feature points. And there is also a concept of playing against another player. So, for example, there are action cards that may do some harm to the opponent, like the Beloved Binding Redirect card, which is kind of problem. How you, which is just kind of randomly stealing some feature cards from your opponent and exchanging with the random card of yours. Or, for example, there is also a concept of heroes. So every player can have a single hero on table, and you gain some additional benefits, like there are, and I also was inspired by well-known people in the .NET world. So, for example, then there is John Skid hero card, and when you play it, you can remove, for example, all issues that you have, that other people have added against you. So anti-issues is another thing that, for example, you can add a bug to your feature, and then you get less feature points, and so on and so on. So this is all about having fun, about trying to write an app and win simply by gaining the first the appropriate number of points. And because I'm a programmer, obviously, even if it was physical game, I thought, but I need to program something. So I programmed creating the cards. Like I have a SVG prototype of a layout of the card, and then Excel file which is just describing every card, and the C# code which is then changing those templates to particular cards, like cards of all all the cards are created from this template, which is now nice because I will reuse it in an online version. Like I have vector version of all the cards. I have nice template, and now I can plug in all the creation of those cards inside my game. So it will be very nice way of prototyping, changing some things, and then the graphic of a card will be automatically updated during the build phase. So that was nice work even for that. And by the way, I haven't mentioned that yet, but I plan to make it open source. So I try, I hope people will just try to balance it, for example, we're playing, or they will find some interesting ideas to be added. So it will be also beneficial, because if someone will find that, for example, Ben Adams shouldn't be so powerful that that you gain 2 feature points, then maybe there will be a PR to reduce it to 1 or so. So it will be open sourced, and everything then will be simply updated.
But I love the idea. I love the idea that you have of having these concepts that are sometimes hard to understand and making it fun for you to learn. So very cool.
That's the whole idea, to try to introduce kind of those concepts to every .NET programmer, or even outside this environment. So there are cards about span of T, there is a card about stack alloc, there is a card about memory leak, and so on. So and some tools that people are using in this area. So by playing, you simply learn a lot also about this stuff. You start to know things. And that's one of the goals, by the way, to not only play and have fun, but learn and teach, maybe.
So who do I want in my deck in terms of heroes? What's going to get me the most, points?
I really try to balance them all, so there is no one the most powerful, but I'm not sure if it works. So we will see, simply. And the list of heroes, you can download, by the way, this sheet of all the cards, so we can look later on. I don't remember even all heroes, because that stage was last year, so I don't even remember all the heroes.
Well, one of our audience members have asked, and I had the same question actually. Is there a Konrad Kokosa card?
I was very tempted about that, but no. But there is a book. There is a card about my book.
Cool.
So it is, and obviously it reduces allocations, because it is about memory management. So, and the whole concept is here that you build 3 types of applications. You need to choose which you are building. So, for example, and they are represented by colors. So you see color of blue, which was it was a commercial app. So you add features like you are adding mobile app to your e-commerce application, or you are starting to handle cryptocurrency and so on. So, and there is a game, and there is a social Facebook 2 app that you may try to build with that. So also I see here a huge field of improvements in terms of what you can learn. Like you can start to add Blazor here, static web apps and other stuff, and we'll also start to learn about additional things that are in the ecosystem by, for example, a bonus expansion packs. So there might be an expansion pack about Azure serverless technologies or so.
Yeah, I can see an AUI expansion pack there as well.
Well, and I feel like that opens an interesting question, because you mentioned earlier that it's all open source. So how, I feel like managing an open source board game would be an interesting experiment on GitHub. Like how do you do like the pull requests and the feature releases and all that when the product is a card game? It seems like an interesting project.
It is kind of risky even, but for sure it is experiment, and we will see, because I really hope the community will help. Like I really hope that the community will start to drive the new cards, for example, or the balancing the existing ones. So I really hope it will work simply by that. People start, because it's one thing is playing, another thing is that the feeling of control, that you can improve things, add something. So we will see. We will see.
We're hearing from the audience that they're already asking for a ML.NET card, and I think
Maybe
Luis can probably help with that.
I approve that message.
ML.NET expansion pack even. Yes, that's true. There are AI bots or so. Such card exists already, but for sure we can add more stuff related to that. So, but the problem with the physical is that the physical version is that it really needs a lot of time to get some visibility. People needs to buy it, probably because I would be not able to get it for free. Like now there is this free version that everyone can print, but it is pretty problematic, and not everyone will be willing to do that. So having it as an online version may be a really boosting the whole popularity of the thing. So that's why I decided that last year probably, let's go online and let's use Blazor for that. Mostly because I really find it suiting this use case, because this is a card game, so a lot of things is happening on the client side, and I can validate how people are playing. I can validate some rules. I can react on things that are coming from server side. So obviously I could do that in JavaScript or TypeScript, but I'm not a fan of JavaScript or TypeScript. I simply, maybe not because it is bad, because I don't know it well. So I will not be able to simply do that in JavaScript. And then I thought, okay, but Blazor is something that is really fitting this scenario, because all the things are in C#, and I can write both logic of validation, both rules, definition of the game, definition of cards, everything can be written in C# and shared between, for example, client and server. So that's something super nice for this scenario, I believe. So I was not sure what is the level of knowledge here about the Blazor. So maybe I'm not sure whether I should introduce Blazor WebAssembly in general, but let's just assume that I will take 1 minute for explaining it. So WebAssembly and Blazor WebAssembly is super nice because you have a C# application, which is then full application with the help of Razor views and so on, but it is all written in C#, and then it is run inside the runtime that is running in WebAssembly. And for that, in the whole runtime, in fact, is recompiled to WebAssembly. So when you go to the page which is using Blazor WebAssembly, you simply downloading, you can say, the whole runtime, which is compiled in WebAssembly. Obviously, it is also cached, so it is not so, it doesn't happen every time you go there. But the whole runtime was and is recompiled to WebAssembly, and then if you have a runtime, which is just now any regular runtime, the only difference is that it is running in WebAssembly, so the browser is able to execute. Then you can feed it with any .NET application, in fact. So you can put their console application and print to the console, and it will be just interpreted as writing to the console in the browser. But obviously above that, we have the whole Razor and the whole Blazor, which is then another layer, which is a lot of code that allows us to write with the help of Razor views and the whole logic, which is talking with the HTML and has JavaScript interrupt. So a lot of additional things that are, but the whole idea, and I was really, when I first saw that, I was really liking the idea that let's recompile the whole runtime and run it in browser. It was kind of head explosion for me that it is working. and it is working in the end so well. So it is inspired me a lot. So just a kind of another thing that, because I'm an internals guy, so I need to explain some internals. At the very beginning, when the prototype was shown, .NET Anywhere was used, which is, by the way, a super nice runtime written by a single guy from Google, Chris Bacon. And it was used because it is super simple runtime written in C, so it was pretty easy to recompile it to WebAssembly, but it was obviously too limited to be a full production ready runtime to be used. So after some time, the decision was to migrate to use simply Mono, which is much better runtime for this approach, which is for the very beginning written in a multi-platform way, and it has a pretty good interpreter, and we will return to that in a moment. So when we are writing something in Blazor WebAssembly, the final process looks like that you are simply writing your application in Visual Studio or whatever tool you would like to use, and you are also including to your code as a dependency, as another dependency, a NuGet package and the whole tooling, which is including this runtime precompiled to WebAssembly. But obviously you don't need to do that. You are just getting this as a dependency, and it will be Mono because of the it is just good fit here. And then you simply build your application, and then magic happens because you are hosting the whole thing, for example, including static web apps. And when the user is going to your site, there will be simple bootstrapping JavaScript code that is downloaded and starts bootstrapping all the things. So it starts executing this Mono runtime, which will be then populated with your with your dependencies that will be also downloaded. And by dependencies, I mean your assembly and all the assemblies that are needed to run your application. So simply, for example, if you have a simple console app, there will be also system DLL being downloaded and some basic ones. If you are using Blazor, obviously you need assemblies of the whole Blazor to be downloaded, although this may be also optimized, and with the help of trimming, you will be simply producing the single set of files or even single file, which will be providing you the whole thing. But the thing that I would really like to explain today, like when you are running Blazor WebAssembly, you are simply starting the separate runtime inside your browser, which will be Mono running and being recompiled to WebAssembly. But the DLLs and all the things that you are populating the runtime to be executed are just regular DLLs, regular files with IL inside. So
And
a
quick question there, Conrad. So you coming from like a resource management and making sure that things run and perform well. Have you found any sort of downside to having the runtime or everything coming down onto your application? And if so, what are some ways that you can improve either the startup or how well your application performs?
Yeah, so that's the thing that Microsoft is working now currently extensively, because the obvious thing is you have to download the runtime. So it is few megabytes, or it depends how you will compile it. But let's assume, for example, that your page will take 3 or 4 megabytes, which is some size. Like it is not trivial size for some scenarios, even if you are using mobile connection or so. So that's a kind of problem. And there are technologies for improving that, like IL trimming, which will be trying simply to get rid of everything that is not needed, because by default you can just populate your app with every assembly and every type and every method which is inside. But typically you will not use most of those methods and types. So technologies that are out of the box provided allows you to trim all the things that are not used. So it will help, and when you build in the release mode, you can enable doing the such things. So then it will for sure help, because the things to download will be smaller. On the other hand, there will be problem because Blazor WebAssembly is running currently in the interpreter mode, because browsers doesn't allow you to JIT anything to any memory that later on would be executed. So the only way how the mono currently may execute our IL code is simply to interpret it. And that was one of the reasons, as far as I understand, why the mono was chosen, because it has pretty decent, well tested an interpreter. So when we are executing our app, there is no JIT like in a regular .NET application, but we simply, and not we, but the runtime is taking your assembly and interprets your program instruction by instruction, IL instruction by instruction. So that is not super beneficial from, let's say, performance perspective, but from my experience, it works pretty well. I would say surprisingly well. So I'm not seeing any super problems with that. Although for sure, Microsoft is fully aware of that fact, and in .NET 6 there will be a OT being provided ahead of time compilation. So that will help a lot, because now it will totally change how you deploy your app, how you can deploy your app, because then it will be not IL being deployed, but it will be your application being directly compiled to WebAssembly ahead of time, which is super nice. Like now there will be no interpreter, there will be no JIT, and simply your magically your .NET application will be executed directly as WebAssembly code. And I'm really waiting for that. I was not trying to do that for my game yet, but I expect, and we can find even already pretty nice benchmarks that shows that it really speeds up, like 10 times or bigger achievements maybe here. So that's one of the answers, because it will start run of the application, because there will be no JIT, there will be no interpreter, your application will be ready to run immediately. But on the other hand, WebAssembly code tends to be twice bigger, at least a little bit bigger than the IL code. So now there will be this compromise. Simply you will need to choose between the speed up time and the size of your assemblies, whether they should be recompiled to WebAssembly or maybe they should be simply interpreted. And the approach is, as far as I understand also, that you will choose, like, this part of application should be AOT compiled, this part should be interpreted. And now you will have this decision to decide what's important for you.
Awesome. Thanks for that really in-depth explanation there. Yeah, so I thought you might have a thought or two, considering that's sort of your background. So thanks for that.
Yeah, I'm not sure if I'm jumping here, but why did you choose Blazor for your game?
Yeah, so because I really wanted to go serverless, because I would like to see a lot of people playing it, and then I will be afraid about, unbound costs of any kind of server hosting. And if I can go serverless, then I feel I have much better scalability, because some of the costs are just off my deployment, and people are simply paying, let's say, about it, because they execute their code on the client side in the Blazor app. So it's a win-win situation, because in the end they are not paying anything and I'm not paying anything. So the most logic that can be in the Blazor, the better for me. And obviously I also need some server side, because I have an engine which will run the whole logic of the app. But again, I feel serverless Azure Functions will help here a lot. Like their scalability will help a lot. They will just allow and align to the traffic, because for sure it will be not constant. So I feel it is super nice combination. Offloading calculations to client and then making as little calculations on the server side, let's say, because of the serverless Azure Functions. So I fit it much better. And Blazor, because it is in C#. So obviously I could try to do something similar like in TypeScript or JavaScript, but I would be blocked by my lack of knowledge. So I would just be not able to do that.
And I think that's a huge appeal of Blazor, is that you can continue to use the C# you know and love, but to build those cool web applications. And we saw the same with the try.net, like that sometimes people will see on the Microsoft Learn and the API docs where you can run the sample interactively, is that we had a huge build after our first month, and then the .NET Interactive team, they converted try.net to Blazor WebAssembly because of those huge costs. So like that's something for people to consider when doing that. So
that's true. And what I also love is this sharing of data. Like I cannot, there is no things like whether it will be converted somehow by JSON to be sent to client or so. I have just a class that defines my game, and all the definition is just C#, and it is the same shared library that now I can use both on server side and client side. So the whole cards, definitions, and it is not about only sharing data, but also methods, algorithms. Like if there is a method in my shared project, both client and server can use them. So that's for me super, super beneficial, because then I will just need to rewrite it to TypeScript, for example, or JavaScript, which would be making the same twice, which is always error prone, and a lot of time is doubled simply. So that's super beneficial. So I decided to use the template and the way of simply hosting it with the help of static web apps, because I don't feel a need for having ASP.NET Core hosted something on the server side. Like I can really serve all the Blazor things that I need, and then that's all. If I will need an API, then they will be handled by Azure Functions. And what's funny is that I decided to do something like that. I started to Google, and then I found, but you have already done this. You have this static web apps generator, static web apps way of configuring it exactly like that. You have API with the help of Azure Functions, and then you have a client as you presented at the beginning. So I really like, for me, Blazor is this configuration, which is for most appealing for me. Blazor WebAssembly, because I can offload calculations to client, static web apps, because I can, let's say, cheaply host all the thing, and then Azure Functions, because I have scalability on the server side for an API that is consumed by the clients. And and this is exactly what have you shown. I started to work on that like in September 2020, and the Azure Static Web Apps helping. It was something in preview as far as I remember, but now it is out of the preview. So this is just this tutorial that you have presented. And if anyone watching us now would like to experiment with that, I really encourage you to make exactly the same steps like it was shown. So use this GitHub repository as a template. My game is even now still having this created from this template because I started from this template. And then you create a static web app, and then we have super nice preset. That's the matter of choosing the preset and specifying in which folder which part simply is. So that's even nicer because you don't need to do anything in the end. The template here on the side of static web app will handle everything. You need to simply say that you will have an app location by this folder named client, for example, and API in terms of Azure Functions will be in the folder API, and that's all. And then you create this static web app, and the only thing which changes in the end is an additional build and deploy step, which will be responsible for creating all the things and hosting them. Obviously, this is for something I'm not decided yet, because here it is a pretty simple model. When you directly expose the API, maybe there should be some kind of load balancing or maybe kind of throttling or something. I don't know. For this purpose that I'm currently and at this stage, it is totally fine. So I have experimental setup in few clicks of the both client and the API. And so I made some awesome drawings. I even downloaded the icons of Azure to make it aligned with the typical Azure way of showing the architecture. So now just a few slides about the whole architecture. So I have a Blazor WebAssembly application, and as I hope we have explained it a little, Blazor WebAssembly is just a set of files. They needs to be simply somehow hosted. It can be hosted by FTP or Python or whatever you want. It is just a set of files that needs to be downloaded to the client, and then the execution will be on the client side. So for that manner, I'm using static web apps simply because I have this nice template. So when you go to the site, you will download the whole game as a Blazor WebAssembly game from static web apps. Then obviously the question is, what's about authorization and access to it? So because it will be kind of prototype, I would like to start from possibility to play without registering, but that's maybe a separate thing. Let's assume that people needs to register and log in. So for that, because I'm going serverless, I'm using authorization as a service platform. For that, I decided to use Auth0. That there could be anything else that is just giving you a possibility to authorize the user, and you return with a token. So then you can use it to access your API, for example. So then will be the second step. The user from your application, from the Blazor WebAssembly application, will start to authorize itself. There is now pretty decent, nice support in Blazor WebAssembly. So you say, for example, this page needs to be authorized. You plug in proper providers, and let's say the flow happens magically, simply on the UI level. So it is nicely supported already. And in the end, you have an access to the page, and you have a token and the whole authorization provider from which you can from which you can get a token, for example, then to access other things.
So we have a related question here from Cedric Jr. here. How about authorization? Can I find user permissions for specific functions? And you kind of went over authorization, but I just want to make sure you're doing the authorization at the page level in your WebAssembly app rather than at the function API level. Is that correct?
Yes. So in fact, on both levels. So when the application is authorized, then I need to authorize on the page level to go to the page, for example, of a game. But then when I will issue API calls, which is even presented a few slides later, I'm using a token from this authorization, then a JOT token. So API level is also protected because I will then validate this token on the Azure Functions level also.
Great, thanks.
So we have something like that. And obviously the second important part is here the functions itself, because I cannot trust the user. I cannot trust any client in case of any game, which is multiplayer game, because people may cheat. I need to validate all the moves. If clients is saying it is playing a specific card, I don't believe. I really need to check whether the state allows him or her to do that or so. So there is a whole logic for that on the server, on the function, which is just reacting to some comments. So I'm having here kind of CQRS, let's say, because when I'm playing a card, I'm saying from Blazor WebAssembly information, player A has played card with ID something, and then the whole machine on the engine level of the game, which is inside the function, will now decide how to react to this comment. It may even decline this comment by saying it is not a valid comment for that particular moment. The player doesn't have this card, or maybe it is not the move of this player. So the comment may be rejected, but also it may be accepted, and then the whole flow of reacting to it starts. And here now we are using this token, which we have obtained from the authorization server. So the API is also protected. And because I wanted to make it even more fancy, I need some storage, obviously, and I wanted to make it also, let's say, scalable to the without no limits, assuming it will be used by millions of people. I decided to use Cosmos DB because it is also a nice thing to play with. So the whole thing about, for example, persisting the storage of the function is in Cosmos DB. So there is simply...
I was actually going to have a question about that. So during gameplay, is there, if you're doing everything in Azure Functions, so I guess the gameplay itself isn't stateful. There's not like a web session somewhere on a server somewhere containing the game information. It's all stateless back in Cosmos. Is that right?
That's right. Although I assume Azure, when it's executed, has some delay before it is being killed, so I will be able to handle multiple commands before the instance will go away. But I'm not assuming anything. So if it will be like I will need to instantiate a new function per every comment, it will be working like that. Although I hope it will be not, because it will be not super efficient. But there is no state in the Azure Functions itself. So the flow is, if I'm handling a function, if I'm handling a comment in a function, I'm trying to get something from cache. But if there is no cache, because this function is fresh, and there is no state yet for this game, I'm getting it from Cosmos DB, and I'm also immediately updating it. So the whole through about the state is in the Cosmos DB. And then the second direction, because when I'm executing my command, this is kind of DDD-ish approach, because I'm treating a game as a kind of aggregate root, let's say. And if I'm having a command, I would like to react with events. And then those events needs to be broadcasted to all players. Although currently I'm developing it as a 2-player game, mostly because I don't know how to handle more players in a nice UI. But let's assume there are 2 players. So I have to inform now the other players, or even the player that has issued a command, what happened. And for that, I'm using another fancy thing, which is SignalR, because it is just a nice technology to have this bidirectional communication, although here I'm using it mostly for server to client communication. So all the functions, when the command has been accepted and I know what are the reactions, then those events are broadcasted to other connected clients with the help of SignalR. and because I really wanted to make it serverless, so I'm using another serverless service, let's say, which is Signal R service for having this communication back to clients. And in the end, all those are all the pieces. So it may be seen as a complex one or maybe a simpler one. For me, it is pretty clean architecture, and it allows to offloading now a lot of things, as I said, because I can make some calculations in client, I can make some calculations in functions. On the level of deployment, everything is shared. And I see a lot of scalability, not problems, but possibilities here. Like all those technologies are for scalability. So I'm ready for you players.
And touching a bit upon, right, a lot of these components, because some of it comes from a template, you could just self-host a lot of this and still,
Yes.
you know, even lower the cost, or, you know, still take advantage of those cost efficiencies that you built in.
Yeah, but that's probably how it will end, because I will have better control over the whole stuff. So this template was super nice kickoff, but the final repository probably will be. I'm even thinking about splitting it because, you know, keeping in mind it will be open sourced, we need somehow to have kind of separation between how people can try to influence, and I don't see they should have control over the deployment, for example. So we will see, but that's the value point. Like for sure, I will in the end host it manually, not with the help of the template. So this is how it looks, and what I can say is that it is working really nice. So I haven't met any blockers, like I was trying to invent this and do add this or that to Blazor, and I was really surprised. And I'm not saying this and because I'm not a marketer or seller, or I'm not paid by Microsoft in any way, but I was really surprised by how those things are working. Even a lot of them is in preview. Like I'm also doing stuff in preview. I'm doing this all in preview 6, .NET 6 preview 4, and it really works. So it is really nice. And that's, I believe, mostly all. Obviously, then I will add some logging probably. I will decide how to do that. What is nice here also that it is super open for event sourcing. So I haven't yet decided whether I should take this approach, but for sure I can log every comment and every event and every reaction. From that I can have a huge history of all the plays, and this will allow me also to balance things, because I will see, for example, that players using particular cards or always winning or so on. So a lot of analytical data here will be also at hand when if people will play it. Obviously, if no one will play.
So, Conrad, for some future show, I'd like for you to come show us what you have cooked up with App Insights in Blazor, because I know that's an area that there's like a whole new layer of complication there.
That's probably, I haven't touched it. That's why it is grayed out. So we will see what the future will bring. And currently, I'm not sure if we have time. Probably not so many. This is still in a work in progress. Obviously, I was hoping it will be much more advanced when I was planning to have this talk. I need still probably have some months to make it. And what is important here also, which was not yet mentioned, is the Blazor, let's say, view part, because in general, what I like in Blazor is that there is approach which is promoting simply using components, and we should write components in Razor and set up everything in C# with the help of properties and so on. And that's super nice. But unfortunately, I haven't found it useful in my case, because game is just super visual. And I need a lot of animations. I need to shake a camera. I need to have a layout of cards. So, I have to refer back to JavaScript. Fortunately or not, but I wanted to use something more fancy than having just few divs laid somehow by my very poor design skills. So I decided to use Phaser AO. There is this library which is for that's not pretty nice framework for games in JavaScript using Canvas and HTML5. So what I'm doing here, and also getting some, let's say, experience, is how you can use such component in JavaScript and wrap it inside a Blazor. And that's super nice also that it is supported. So my game is rendered by JavaScript, and this should be treated as a kind of view layer, but all the things, all the logic, validation of requests, sending requests, comments is done on the layer below in C#, and still it is all in Blazor packed in this application. So that's super nice that there is this JavaScript interrupt. So if obviously a lot of components already exist, and you can use a lot of them, like even JavaScript components, popular JavaScript components like Chart.js or other are already wrapped inside components, but unfortunately Phaser was not. So I'm having here also some fun to separate that, and that would be probably also a separate talk, how you can use this thin JavaScript layer, which is for viewing, rendering, and all the stuff is handled by C# code.
And you mentioned earlier that that it hasn't been open source yet, right?
Yeah.
Okay, so I think make sure to share the repo once it's live, so we can share with our guests.
Probably I could share it already, but I think it will be more beneficial when I will share it at the same time when I will just expose it for publicly for players. So then people start to play, and they will have a link. If you are interested, you can issue some additional things, add some PRs or so. So
I was just going to say, I already have some feature ideas, and I haven't even seen the app. Because we're streaming, right? And I've noticed that a lot of video games lately have added features for streamers, right? Things that build in like audience participation. Right. So I'm envisioning this game because I really want to play it. I'm looking forward to it. Like, I'm feeling some of the same feelings like yesterday. If any gamers are in our audience who maybe watched like the Xbox E3 presentation yesterday, right? You feel that, oh, this game's coming and I want to play it. I'm feeling that right now, but I'm feeling like, oh, we ought to do it on stream, right? We ought to, however many people the game can play, we ought to get everybody on a StreamYard session and play it live, and some kind of audience participation would be really cool.
Absolutely. That would be awesome. And by the way, I haven't investigated it also. I haven't investigated it a lot, but Blazor is so close to progressive web apps. So maybe we can just make it, out of the box, have it as a desktop app, simply that you can just have it and have this nice icon to be double clicked on desktop and start playing immediately.
So we're coming to the end of our stream. So if people want to check out the game, what is the website again?
So at this moment, they can use this one, which is about this print and play version, but just there is a newsletter. For the best way would be just to sign to the newsletter, because I will be just broadcasting any updates there about it. And eventually, in a few months, I hope it will be just changed from this print and play version, and this will be an address of the game itself. So there will be just the address of the game. Or you can just
Awesome.
return to this address in a few months and see whether something has changed.
All right. Thank you so much, Konrad, for coming to the show today. We really look forward to seeing the game open source and be able to play online and see all those concepts coming together. And thank you, everyone, for watching the .NET Docs Show. We'll be coming back next week with more, and check out we have like past recordings, so you can go to .NETDocs.dev to check all the information about our show. And next week we have Faridun Barry Katz, I'm probably butchering the name, with React and ASP.NET Core Web API. So join us next week. Thank you.
Thank you.
Bye, everybody.
Bye.